I'm Antonio Lobefaro from TERA, and I will present a complete IoT backend infrastructure in Fiware. Okay. This is my company's logo. Who is TERA? TERA is an SME that that is active in different fields, application fields: energy efficiency, environmental monitoring, predictive maintenance, ICT, and mechatronics. We are located in the southeast of Italy. What do we do? We have two gateway solutions to collect data from different kind of sensors. We have Beta. This is Beta, designed to be a home solution, and also Joe, designed to be an industrial solution. We are able to, this gateway are able to collect data from different kind of sensors. Different not only in which kind of value they collect, but also in protocols that they use to communicate. Just to have an idea, for example, we have a Z-Wave smart plug, we have a Zigbee presence sensor, we have a Modbus energy meter. So these gateways are able to collect all this data from these devices on the shelf that some devices you can find on supermarket, for example. We don't want to provide devices, but the solution to collect data from these devices. All this data are collected and will send to the cloud. So the data collected in the cloud and elaborated with different algorithms will show on a dashboard, a web dashboard. So the user will be able to have a business intelligence, to aggregate data, to show to see the charts, and moreover. Okay, so about the cloud solution. In the cloud solution, we are developing a Fiware solution, our Fiware solution. So, what do we need? The gateway sends data with an MQTT protocol, but also in other different lightweight message protocol. And we need to translate this language in an NGSI protocol, able to communicate with the Orion Context Broker, or Ion Context Broker, sorry. So we need an IoT agent that translates our MQTT messages in NGSI message. So the data will arrive to the Orion Context Broker that need a MongoDB to elaborate data, and we need to collect data, to store data in a DB. We use MySQL. Here you can see MySQL DB, but we also can use a MongoDB or a big data like Hadoop. Okay, in this configuration, we want to develop this configuration. How to do? We use the Fiware Docker container service. That is a container that is able to deploy the different the different containers with the different services. How to do? Okay, what is Fiware Docker Container Services? Here we can see the infrastructure of FDCS. Every time that we want to develop a solution like this, we need to have a key, a tenant, an ID from the keystone, and a tenant ID. The tenant ID, thanks to the tenant ID, we will have our space inside the FDCS, and we will be able to deploy our solution. Just when we deploy a solution FDCS, there is a problem. When the FDCS give to each container, deployed container, a new IP and a new port. So we need to know this IP and we need to know these ports to deploy our solution. So here we can see how the space is distributed between the tenants on the FDCS. So what we need to do? We need to connect the different modules each others. So we need to connect the IoT agent, the Orion Context Broker, MongoDB, Cygnus, and MySQLDB. And in some cases, we need to know the IP address of each of these modules and also the ports. The problem, when we when we adopt a Cygnus solution, we need to configure the Cygnus with some parameters. For example, we need to say to Cygnus, where is MySQL, and on which port is listening. But before we are not able to know these parameters because we need before to deploy the solution on FDCS. So we created two Docker Compose. In the first Docker Compose, we have MySQL, the IoT agent, the Orion, and MongoDB. And this is a part of the file of the Docker Compose. Here we can see the image of the different containers, the port exposing, and for example, the volumes. And also we are able to see the connection, for example, for the IoT agent that is connected to Orion and Mongo. But in this case, we are able to do this because we don't need to write a file with these parameters. So after run this compose, this Docker Compose, we are able to know the external port and IP of MySQL. With the command docker ps, we are able to see the IP of a different container and the ports. So now we can insert this in the Cygnus file agent. Okay, we have another problem. Cygnus, if we have the Cygnus image, we build the Cygnus image, we are not able to write already the configuration file. So what we do? In the Docker Compose of Cygnus, we can insert two environment variables, and we can set the MySQL host and MySQL port. automatically these ports will be set in the configuration files of Signas. Okay, when the two Docker Compose are up, are running, we need to make a subscription of Signas in Orion. And how to do this? We need to execute this kind of command that make the subscription and say to Orion where is the Signas URL and the Signas port. So at the end, we will have this kind of solution. We have a Docker Compose with the different modules deployed, the different ports exposed, that become external dynamic APM port, not static. We are not able to control IP and ports. And we will be able to connect Signas to Orion and also to MySQL. So the solution that we are going to do is done. This is, there are these steps that resume what we have done, and we want to, the next step is to create a script able to do in a single command everything you read here. These are our reference, the reference of TERA. If you have any question in future, you can write us an email, and you can follow us on LinkedIn, Twitter. And if you have questions, I'm here. No question? It's okay. Thank you.